Understand you soon, it won't be long. Keep on, keep running. So we're going to look at laws of indices in relation to both algebraic and numerical values. So, as you can see on the screen, we've got different laws of indices. So I'm going to put some numerical values in so we can actually see them in algebraic form. So if you look at the law number 1, which is to multiply two powers with the same base, you add the indices. So we've got a to the power of m times a to the power of n, and we just add the two indices together. So if we had a to the power of 3 times a to the power of 2, my answer is going to become a to the power of 5. So I'm just adding the two indices together. Okay, second one. To divide two powers with the same base, you should just subtract them, so you do the inverse of that. So let's say I've got a to the power of 3, and we've got divide by a to the power of 1. That's going to give me a to the power of 2. So I do 3, take away the 1. That's going to give me a to the power of 2. Looking at question 3, or rule number 3. Okay, to raise one power to another power, multiply the indices together. So this is usually going to be seen in the format where we've got a to the power of 3 all squared. So if we've got a to the power of 3 all squared, okay, then what you're going to see is I'm going to just multiply those two powers together. So 3 times 2 is going to give me 6, so that's going to give me a to the power of 6. If we're looking at the fourth rule, to raise a fraction to a power, you add the power to the numerator and the denominator in turn. So if we've got a over b all to the power of 3, I'm going to end up with a to the power of 3 over b to the power of 3. So I would raise both to the same power. Okay. And then rule number 5 is to raise a number or a fraction to a negative power. Apply the positive power to the reciprocal. So because it's a negative power, that's going to turn it from what it actually is to the reciprocal of that, and then I'll raise the base to the bottom to the positive power. What do I mean by that? A to the power of negative 5, for instance. I'm going to put it 1 over, that's my reciprocal. Remember, this would be a negative 5 over 1, because it's in effect a whole value. I'm going to raise it to reciprocal, so 1 over a to the positive 5. So I'm flipping it upside down as the reciprocal, and my negative power turns into the positive power on the bottom. Okay, as it says down the bottom, there are two more important things. A to the power of 1 is just itself. So if we did 3 to the power of 1, for instance, that's going to equal 3. And if we did 3 to the power of 0, anything raised to the 0 power will equal 1. Okay, it doesn't matter what value it is. It can be a to the power of 0, like it shows in the example. A to the power of 0 equals 1. 3 to the power of 0 equals 1. So anything to the power of 0, doesn't matter what the base is going to equal 1. Okay, let's have a look at some examples in practice. So simplify the following, leaving the answers in index forms. I'm going to leave them in index form. So we're multiplying the first one, so we're using law number 1. Okay, if you want to check the laws back up, just rewind the video. Okay, so I've got 3, and remember my powers, if I'm multiplying them, I'm adding them together. So I've got 8 plus the 5. That's what I'm going to do. So 8 plus 5 gives me 13, so that's going to give me 3 to the power of 13. If I'm looking at b, we've got a fractional value. Now remember, if it's a fraction like this, that's just the same as writing 10 to the power of 8 divide by 10 to the power of 5. So if you think when we multiply the powers, Okay, we add them together. When we divide, we're going to subtract the powers away. So I'm going to write this in the format at the top, being 10 to the power of 8 subtract 5. Okay, so all I'm going to do is do that function on the powers. 8 take away 5 gives me 3, so that's going to give me 10 to the power of 3. Okay, so whether it's written as a fraction or in this context, you do the same thing and subtract the powers. Looking at the third rule, okay, I've got a power raised to another power, so I've got base number 2 to the power of 7, and that is going to be all squared. I'm going to show this in two different ways. The first way is as it is there, so remember we multiply the powers together in this case, so my base is 2 and I'm going to do 7 multiplied by 2, which is going to give me 2 to the power of 14. If you want to think about that in a slightly different way, remember if I square something I just multiply it by itself, and because the bracket is around the base number and base number to the power of 7, I'm multiplying the whole of that by itself. So I'm actually doing 2 to the power of 7 multiplied by 2 to the power of 7. So if it helps to think about that in relation to the first law, we would end up then having 2 to the power of 7 plus 7, which is going to give me again 2 to the power of 14. So whichever way you want to try and think about that, okay, that's what's happening using the third power, the third law. Okay, looking at D, fractional value, so we're going to use this, remember doing the fraction, the power to both the top, the numerator and the denominator of the fraction. So we've got 7 over 5, and if I'm going to pull that to the power of 6 out, it just becomes 7 to the power of 6 and 5 to the power of 6. Okay, and I would leave it as that. So that one's quite an easy one to think. E. So we're going to look at the fifth rule now when I've got a negative power. If I've got a negative power and that negative power, as it says there, is 12 to the power of 5, remember I'm starting with the negative power, so I'm going to turn that into a reciprocal. If my whole number is 12, okay, imagine it is 12, okay, that is just 12 over 1. Okay, we don't write the divide by 1 because it will make no difference to it. 12 divided by 1 is just 12. So if we've got a whole number power, if you imagine it as a fraction of 12 over 1 and we wanted to do the reciprocal, we're going to turn it upside down, and that's what the negative in the power is going to do. So I flip it on its head, so that's going to give me 1 over 12, and remember my power then turns from being a negative to a positive, and it's going to give to the power of 5. So 1 over 12 to the power of 5. And then finally, looking at the last one there, back to rule number 1 for this one, in the sense of a to the power of 7 multiplied a to the power of 3. Now you can see my base number in this sense has now changed. It's become a letter as opposed to a number. So in algebraic method, the formula is exactly, or the process is exactly the same. My base is still a, and I've got to the power of 7 plus 3, so that's going to give me a to the power of 10. So the rules still work exactly the same with algebraic values as what they do with numerical ones. Okay, let's look at if we've got them in a calculation. So we've got more than one particular calculation going on at any one time. Normally we'd use BIDMAS whenever you've got any calculations mathematically. So we're going to look at this, and remember when I do multiply and divide, okay, BIDMAS divide comes before multiply. So I could follow that rule of doing the divide first. It's not going to make any difference to this particular function. Or I could do it both at the same time, starting from the left of the function and going through to the right. Okay, so I could do 2 to the power of 6 times 2 to the power of 8 first, and then divide by 2 to the power of 2. Or I could do 2 to the power of 8 divided by 2 to the power of 2, and then times it by 2 to the power of 6. Both will give me exactly the same answer. So let's do this first one. So I'm going to do the multiply first. 2 to the power of 6 multiplied 2 to the power of 8, so I'm just going to add my powers together, which is going to give me 2 to the power of 14. Then I'm going to divide by 2 to the power of 2. So if I divide that by 2 to the power of 2, that's going to give me 2 to the power of 14, take away 2, which gives me 2 to the power of 12. So I've just done rule 1 and rule 2 to solve that first question. We're going to do exactly the same now in relation to B. The only difference this time is I've got rule 1 and rule 2 in a fraction, and the fraction actually means I'm going to divide the numerator by the denominator. I'm going to divide the top line by the bottom line. So let's do each line on its own. So we've got 2 to the power of 3, add 5, so that's going to give me 2 to the power of 8 on the top. Now do the bottom, 2 to the power of 8, subtract 2 to the power of 6 is going to give me 2 to the power of 2. Now remember, this is still a fraction, it's still in fraction form. So if I wanted to write that out again, I've got 2 to the power of 8 divide by 2 to the power of 2. So I'm going to do rule number 2 again, 2 to the power of 8 subtract 2, and that's going to give me 2 to the power of 6, and that's my answer. So when you think we start with this equation up at this expression up at the top there, 2 to the power of 3 times 2 to the power of 5, divide by 2 to the power of 8, divide by 2 to the power of 6. Okay, and I'm ending up with 2 to the power of 6. That's exactly the same formula. Okay, right. Let's look at part A here. A to the power of 6 times A to the power of 5, rule 1. So A, 6, add 5, is going to give me A to the power of 11. Then I'm going to divide it by A to the power of 4. A to the power of 11, take away 4, is going to give me A to the power of 7. And on to B. Again, we've got to think what rules we've got. This top one here, we've got rule 3 where we're multiplying, we've raised a power to another power, so we're going to multiply the powers together. At the bottom here we've got divide, so we're going to subtract the powers away from each other. And then remember, on the fraction itself, if I take this away, you can see we've got, it's in a fraction, and that's what this line means itself. This means divide again. Okay, so again we're going to use BIDMAS. We've got brackets in the sum, so we're going to do that one first. We're going to do the numerator first. So we've got x to the power of 6, and we're going to multiply it by negative 4. Okay, so that's going to give me x to the 24, and I've got a positive plus a negative, so that's going to give me negative 24. Bottom line, on the denominator, we've got x to the power of 9, and remember we're going to subtract these away from each other. That's going to give me x to the power of 6. Remember, this is still as a fraction, so we're going to do this rule number 2 again, which gives me x to the negative 24, and we're going to subtract the 6. So I'm at minus 24, and I subtract 6 from it, so it's going further into the minuses. It's getting, if it was minus 24 degrees and it gets 6 degrees colder, it would end up being x to the minus 30, and that's my answer. Okay, now just looking at this, if I've got a negative power, remember I wouldn't leave it as x to the negative 30, because I've got one more rule I could use, and I can use rule 5, whereas I am going to now put this as a reciprocal. Remember, it's x to the power of negative 30, and I don't really like leaving it in a negative as a negative power, so we could put that as 1 over x to the positive 30, and that would be my correct answer. Okay, both answers are correct, but it's a nicer way to leave that answer like that, instead of a negative power. Okay. Right, I've got 3 more questions to go through. These are a little bit more complex. Okay, and again, you're going to use the rules of BIDMAS to try and work these through. Question 1, you can see we've got the big bracket with everything inside it, and whatever is in that bracket, when we work it out, is going to be raised to the outside power. So, let's do it a line at a time. So let's do the numerator. We've got 3, negative 8. It's times in, so I'm going to add the power to 3 to the power of 12. If I do that, I'm going to end up with 3 to the power of positive 4. So that top line, the numerator, simplifies to 3 over 4. 3 to the power of 4, sorry. Okay. I'm then going to look at the bottom line. I've got 3 to the power of 2. Remember, that's a divide. So I could write the next line down as being 3 to the power of 4, take away the 2, which is going to give me 3 to the power of 2. And remember, at this point, this is still all in brackets raised to the power of negative 6. So I can now do my multiplication of the power raised to a power, my rule 3, which gives me 3, 2 multiplied by negative 6, which is going to give me 3 raised to the negative 12. And again, remember, we don't want to leave it as a negative power, so we could put that as 1 over 3 raised to the 12th power. 1 over 3 to the 12. Okay, so all of that, think about the rules we've used there. We've used rule number 1 on the top. We've used rule number 2 for dividing it. We've used rule number 3 for multiplying the power raised to another power. And then when we've got down to this bottom bit, okay, we've used rule number 5 because it's a negative indice. Okay, question 2. Again, we do each line at a time. Both of these are divides, so I'm subtracting both sets of powers. So that's going to turn into numerator y, 8 subtract 3, which gives me y to the power of 5. Remember, it's a fraction, and y, 4 subtract 4, gives me y to the power of 0. Now remember, very special ones when we've got to the power of 0. To the power of 0 just means 1. So that's going to be y to the power of 5, divide by 1. And if I divide anything by 1, it's itself. So my answer is y to the power of 5. Part 3. Again, we've got, it looks complicated. We've got n to the negative 18 over n3, n to the power of 3 times n to the power of 6, all raised to the minus 2 power. So again, we're just going to do it part by part. N to the negative 18, I'm going to leave that for the time being. Okay, and you'll see why in a second. If we've now got n to the 3 and it's times in, so I'm going to add the two powers together. Okay, that simplifies to n to the negative 18 over n to the 9. Okay, now remember, we're dividing this down again, so if it's dividing, I'm going to subtract the powers. So that's going to give me n to the negative 18. Okay, and I'm going to subtract an additional 9 if I'm dividing it. That's going to give me n to the negative 27. Remember, at this point we are still inside the bracket, so we've calculated all of this inside the bracket. Okay, and we're left with n to the negative 27. It's just a different way of writing it. Remember, this is raised to the negative 2, and I'm going to multiply this together. So if I multiply this out, I end up with n negative 27 multiplied by negative 2. In this case, remember, my base is still n, Minus 27 multiplied by minus 2 gives me positive 54, because a minus and a minus is a positive, and my answer is n to the power of 54. So if we look at this for question 3, that's how it started, and my answer is n to the power of 54. So whether it's a numerical base number or an algebraic base number, the rules work in exactly the same way. Hope that was useful, and I'll catch you again next time.